Hello students, Namaskar, welcome in online learning process. Today in this video from the topic of electrostatics, we will discuss about electric potential difference, relation between E and V and graphical representation. Now see this electric potential. Read this definition first. It is amount of work done to bring unit positive charge from infinity to that point against direction of electric intensity. I will explain this. Now for this purpose, imagine at point O this plus Q charge is kept. Since charge is positive, electric intensity is in this direction outward. At point A, which is at a distance r from this charge q, we have to bring unit positive charge q0. Now to bring this unit positive charge, we have to imagine this unit positive charge is at infinity where there is no any potential or potential is zero. Means from infinity to bring this unit positive charge at point A, which is at a distance r from given charge, the work is done against direction of this electric intensity. This work done per unit charge is called as electric potential. Now look at this picture, funny picture. Now you may have question why this marked chesta, that is monkey joke, is. I think that some pictures, incidences, places are helping us to remember and remind some concepts. Also, tension freely we have to study. For this purpose, I have shown this. What this picture indicates, can you think about this? Now here, if you will see, this is the plus charge Q and this monkey is bringing unit positive test charge towards this charge Q. Now since like charges are here, the force of repulsion is there. That's why this charge is thrown in this direction. Now look here, it is thrown in this direction. Now to bring this charge towards this monkey has to do some work, and this work per unit charge is called as electric potential. Now we have to find out formula for electric potential due to point charge. Question may be like this: define electric potential and obtain formula for it. About definition just we discussed. Now see derivation part. Now it is starting from diagram. So with me you have to start drawing this diagram. At point O, keep this charge plus Q. Here you have to draw one line and that line is OM. Draw this straight line. On this straight line, show different points, N point and A point. One more thing, this A point is at a distance r from given charge. This M point, it is at a distance x from given charge, and distance between M and N, it is dx. Since charge is positive, electric intensity is in this direction outward. Show this direction also. This is about the diagram. Now we have to bring this unit test charge from infinity to the particular point A. For this purpose, some work is done. We have to find out this work. Clear? Now as per this diagram, you have to write down explanation. Now when we have to bring this charge from infinity to point A, we will consider meanwhile this charge is supposed to be taken at M and then it is displaced to N through the small displacement dx, and during this some work is done against this electric intensity or electric force. That work we have to find out first, and then by integration we can find out total work done to bring a given charge from infinity to this particular point A. For this purpose, after writing this description, we have to find out formula for force. We know this is the electrostatic force, which is 1 upon 4 pi epsilon 0 q0 upon x square, where x is distance between O and M. Clear? Now, when test charge is displacing through this much distance dx from M to N, the work done is force into displacement. This is the basic formula, F into dx, but with minus sign. What this minus sign indicates? Can you tell me? Think about this. This minus sign indicates this work done is against the direction of force. Now, when charge is moved from infinity to point A, to find out total work, we have to take integration from infinity to R of this small work. Do these mathematical steps. Start with me. Now we have to write down this dw, which is nothing but minus f into dx. I have written here. Do it yourself also. Now all of you are expert in maths. Now go on simplifying this. You have to replace this f as 1 upon 4 pi epsilon 0 q0 upon x square. Next to this, now we have to take out this q0 upon 4 pi epsilon 0 as a constant. So integral of 1 upon x square with dx we have to find. Now for this we have to use standard form. This is that standard form. Integration of x raised to n dx from infinity to r. And this is the standard one, x raised to n plus 1 upon n plus 1. Using this we have to find out integration. Do it yourself. चला सुरू करा. What is value of n? N is nothing but, now see I have written here, this 1 upon x square, we can write it as x raised to minus 2, and value of n is minus 2. So this minus 2 plus 1 upon minus 2 plus 1. Go on simplifying this. You will get this minus x raised to minus 1. So this is the value of integration. Substitute here. Now I have substituted. One more point. See this minus sign and this minus sign, it will become plus. And next step is like this. Now we have to substitute these limits, infinity and r. On substituting this, we will get this step. So 1 upon r minus 1 upon infinity. Value of this 1 upon infinity is 0, while constant factor is as it is. Next to this, we will get this step, q0 upon 4 pi epsilon 0, 1 upon r. This is the work done. Finally, we have to find out electric potential, and this is nothing but, as per definition, this electric potential is work done per unit charge. So this 1 upon q0 is as it is, work done, just we got it, substitute here, then this q0 and this q0 will get cancelled, and we are getting this final form, 1 upon 4 pi epsilon 0 q upon r. This is the electric potential. Finally, we got this formula. Speak out in the rhythmic form. Electric potential is 1 upon 4 pi epsilon 0 q upon r. Now we have to write down unit of this electric potential. From the basic formula, V is work done per unit charge. We can write down unit as joule per coulomb or volt. These are the units of this electric potential. Why this is joule per coulomb? Because unit of work done is joule and unit of charge is coulomb. Next to this, we have to define this 1 volt electric potential. What is this 1 volt electric potential? From formula only, we can define this 1 volt electric potential. See like this, 1 volt electric potential is the work done which is 1 joule in order to bring 1 coulomb charge from infinity to the given point against direction of electric intensity. Very simple. From formula you have to remember it. Next to this, we have to see about this zero potential. What is this zero potential? Now we imagine at infinity the potential is zero. That infinity point is a reference point. Means reference point is the point at which there is no any potential or there is zero potential. With respect to this reference, we have to measure potential. Clear? So zero potential is the point at which there is no potential or zero potential, and generally we are taking this point at infinity. Now this electric potential is positive if charge is positive, and just we derived this formula. There minus minus is becoming plus. That's why when charge is positive, electric potential is positive. And second thing, when this charge is negative, this electric potential is negative. From derivation, you can draw this conclusion. Next point. Now, what you think about the charge when it is moving from the point which is at lower potential to the point which is at higher potential? Here, this electric potential increases. Why? Can you tell me? Yes, think about this. Why charge is moving from the point which is at lower potential to the point which is at higher potential? It is increasing. Now see, this is that pictorial form. This is plus charge. Electric intensity is in this direction. These 2 points are shown, point B and point A. And this charge, test charge, is at point A. And when it is moving from point A to point B, out of these two, which is at lower potential and which is at higher potential? Why and why? Yes, from formula you can say about this. This V is inversely proportional to R. So more is the R, less is the V, or vice versa. Means from formula only you can say which point is at lower potential and which point is at higher potential. That's why, of course, A point is at lower potential because A is away from the charge than B. That's why when we are moving from A to B, potential goes on increasing. And second case, opposite to this, when we are moving from B to A, potential goes on decreasing. Electric potential difference, which is nothing but work done per unit charge in moving from point B to point A. Now let us consider this point O at which positive charge is kept. Electric intensity is in outward direction. Here let us consider point B and point A, and to move this test charge from point B to point A, the electric potentials are VB and VA. Now see, what is this VB? It is nothing but work done in order to bring this test charge from this infinity to the point B, which is nothing but VB. Similarly, this VA is nothing but electric potential, which is nothing but work done to bring this unit test charge from infinity to this particular point A. So VB is the electric potential at B, while VA is electric potential at A. And difference between these two potentials in moving charge from B to A is nothing but electric potential difference. So we can write down this electric potential difference from moving charge from B to A is difference in the potentials VA minus VB. That is work done in moving from B to A divided by this Q0. Like this we can find out electric potential difference. Now here we already considered about this electric potential, that is work done per unit charge in moving from infinity to point A. Actually this is also electric potential difference. Now see how. Now again same diagram. At point A plus charge is kept, electric intensities in outward direction at point A, which is at a distance r. From this Q, we have to bring this unit test charge from infinity to this particular point. So to bring this unit charge from infinity to this particular point A, work done per unit charge is electric potential. Now here also two different points are considered. This is the point which is nothing but at infinity, where there is no potential or zero potential, and this is the point A at which we have to bring it. Means this electric potential is difference in the potentials between these 2 points. Which are these 2 points? One is the point which is at a distance r from given charge, and second point is infinity. At infinity, this point is reference point, and at infinity this potential is 0. That's why this is 0. So this Vr minus V0, this is also potential difference, which is work done per unit charge. But we are simply calling this as electric potential because the reference point is the point which is at infinity, where electric potential is 0. Means this electric potential is also electric potential difference. Variation of electric potential and electric intensity with distance. Now see these two formulas. फॉर्मूला है तो सब कुछ है, फॉर्मूला नहीं तो कुछ भी नहीं. सही है ना. देखो, from this is first formula, E is inversely proportional to R square. Means as R increases, E goes on decreasing. This is how the graph of E against R is. As R increases, E goes on decreasing. Second graph, here also this V and R. This R increases, V goes on decreasing. V is also inversely proportional to R, and the nature of graph is like this. As R increases, V goes on decreasing. In both these cases, in this case or in this case, though R increases, V or E goes on decreasing, but mind here, E is inversely proportional to R square, while here V is inversely proportional to R. And combining these two, this is the graph, variation of E or V versus R. Though both are inversely proportional to R, means as R increases, V or E goes on decreasing, but in one case E is inversely proportional to R square, while in this case V is inversely proportional to R. That's why these two are the graphs. Relation between electric field intensity and electric potential. Now see here, this is again same figure. At point O plus Q charge is kept, electric intensity is in outward direction. Consider 2 points, point B and point A, which are separated by distance dx. At point P, electric potential is V. At point A, electric potential is V plus dV. This means change in the potential is dV over this much distance dx. Now, as per this figure, the description is written here. So, you have to write down description. Now, to move this test charge Q0 from B to A, some work is done. Clear? Now, when this test charge is at point P, this test charge will experience certain force. That force is repulsive force, and which is given by this formula E into Q0, because this E is nothing but force per unit charge. This is the basic definition. By cross multiplication, we wrote here as F is equal to E into Q0. Now when this charge is moved through this much distance dx against direction of electric intensity, some work is done, and this work is dw. Now see this work done, which is nothing but minus F into dx. Now further we have to substitute this F, and that is nothing but E into Q0. Just we discussed about this. Next to this, we have to find out this potential, and this potential is nothing but work done per unit charge. That's why this Q0 is taken to the left hand side. So this left hand side is dW by Q0, which is simply E into dx with minus sign. And we know this work done per unit charge is nothing but electric potential dV. So we can write down formula for E as minus dV by dx. So this is the relation between electric intensity and electric potential. So we can write down this electric intensity as negative rate of change of potential with respect to distance. From this formula only, negative rate of change of electric potential with respect to this distance, or this is also called as potential gradient. Thanks for watching this. Thank you very much. Wait for next video. Before going to say bye, read these lines and think about this.